Good morning, students. Welcome to the statistics class. It's been a long time that we have not come together, and this is another one opportunity for us to learn statistics and especially the theoretical probability distribution. And in theoretical probability distribution, about binomial distribution, specifically about binomial distribution. Binomial distribution, when we learned in the last video, you know, binomial distribution is a distribution. When you speak about this name, binomial distribution, you always have to keep it in your mind that for any distribution that we derive, the distribution should have a source. Okay, from where can we derive this? How can we derive this binomial distribution? On what basis we write those values of binomial distribution? On how you can find out the probabilities. That is what we need to understand. The source is all about an experiment of success or a failure, an experiment which has two outcomes, that is success or a failure. If this experiment is repeated, right, n number of times, that is finite number of times, and then we can call this to be as a binomial experiment. And from this experiment, we get the values of the binomial distribution. Okay, like for example, if we are trying to aim at a mango on a tree, that's what the example that I was quoting in the previous. If I am having a stone, one stone, and I'm aiming at a mango on a tree, so for me the range of success would begin from 0 or 1. I can say there is a chance that I may hit the mango, or there is a chance that I may not hit the mango. Okay, right? So there is a chance, one chance of hitting a mango and one chance of not hitting a mango. So 0 indicates I'm not hitting the mango, that I failed in hitting the mango, and 1 indicates that I succeeded in hitting a mango. Likewise, the same thing, the same experiment, success or a failure experiment, if I'm doing it two times, students, right? Two times I'm doing it. So for me, the range of success could be 0, 1, or 2, right? When in those two stones, the range of success can be like this. None of the stone may hit. That means the value of, or the success can be 0. Or maybe in those two stones one may hit, or in those two stones both the stones may hit. So the range of success can be 0, 1, or 2. What if I am doing it 4 times, like I have 4 stones and throwing at that mango? So what can be the range of it? The range can be either 0, 1, 2, 3, or 4. Sir, how? You say if there are 4 mangoes, and when you're starting then to throw, the chance can be like this. All the 4 may not hit. All the 4 stones may not hit the mango. That means you have not succeeded in hitting it. That means it's 0. Maybe in that 4 stones, one stone might have hit the target, that is the mango. Or maybe 2 stones can be hit, or 3 stones may hit, or all the 4 stones may hit. So the range, when we are doing it for 4 times, the range would be from 0 to 4. This is how we need to understand, students. So for any binomial distribution, two elements are important. One is n. N indicates number of times the experiment is repeated. Number of times that success or a failure experiment is repeated. The experiment is repeated. Okay. And P is another element. P indicates the probability of success. This probability of success, this is here it is, you should understand, it remains the same every time you conduct the experiment. The probability of success, we call it as. So these two are called as what for us? The parameters of the binomial distribution. N and P are the parameters of the binomial distribution. So in any of the distribution problems, students, This you need to keep it in your mind, that for any probability distribution there are some key elements. The key elements means parameters. These parameters kind of key elements will be there. And in any problems of binomial distribution, or if you speak about particularly any distribution, the first objective for us is to identify these parameters. These parameters is what we need to identify, students, in the question or from the question. If ever we are not having or we don't have those parameter values given, then means the first objective is to find those parameters, because they are the key elements. They are the important elements. They are the important values that we needed. If we don't have those important values, then we cannot solve any problems in any of the distributions. Likewise, I say in Bernoulli, P is a parameter. This value we should know. In binomial, N and P are the values. These two values you should know. Right. Likewise, there are so many other distributions also, like Poisson distribution. It has a parameter. Hypergeometric distribution, it also has parameters. Then the normal distribution, they also have parameters. Now all these distributions will have parameters, will have key elements. Unless and until we have those key elements found, unless those key elements are known to us, we will never be able to solve the problems in any of the distribution. This is what you need to understand. Okay, so now I have taken some of the problems, 2 marks problems in this binomial distribution from the textbook, students. Those, all those 4 problems are there, not 5. 4 problems are there. I have taken it, the 31st problem, 32nd problem, 33rd problem and 34th problem. Those problems are 2 marks problems, students. Okay, so we'll try to solve those 2 marks problems and make and see that you are very comfortable in solving this binomial distribution. Okay, so keep it in your mind, students. Binomial distribution is derived from an experiment of success or a failure repeated n number of times, repeated finite number of times. Okay, n and p are the key elements for it. N and p are the key elements for it, students. So for us, when we have this, keep it in our mind that we need to first find out those values. Key element values is what we need to find out. If we don't have those values given to us, right, however it is from the data given to us, we should see that those 2 values we should be knowing. If these are known, automatically we can immediately, I can tell you that, okay, I can tell you this type of a problem easily we can solve. Okay, so let's start. The 31st problem. What is the 31st problem saying? Okay, I'll start here. Solution for the 31st problem. It says in a binomial distribution, if n is equal to 6, p is equal to 1 by 3, find mean, median, mode and variance. Very clearly they have mentioned, right, I'll write it as 31. Very clearly they have mentioned n is equal to 6, students, p is equal to 1 by 3, and they asked us to find out mean, they asked us to find out mode and also variance. Okay, so these are their mean, median, mode, and there's features we have, students. Those features I have explained to you in the previous video, so you can go through that and see. Now how do you find out mean of a binomial distribution? Is given by, as you know, okay, we say the expected value of x, and it is given by the formula as n into p, students. What is n? N is 6 and p is what is 1 by 3. 3 ones are 3 twos are, so that means mean or the expected value of x is 2 of this binomial distribution. Then mode. Okay, what is the mode? Fine, so since it's an integer value, okay, so since this np is an integer value, so very clearly we can see it that mode also is 2, students. Mode also can be taken as 2. Okay, and variance. What is variance? Variance of a binomial distribution is npq. n into p into q. That is, n is 6, p is 1 by 3. When p is 1 by 3, q will be 2 by 3 students. Okay, how do you say, sir? P is for success, Q is for failure. Just imagine, it is all about 3, right? It's just imagine when we are doing it for 3 times, or when we are throwing a stone at 3 times. In that one time you have been successful. That means it is 1 by 3. Out of 3, once you have been successful. Then how many times you have been a failure? That means 2 times you have been a failure out of 3. Is it right? So like that, P represents the success, Q represents the failure. This is how I have written 2 by 3. Okay, so 3 ones are 3 twos are students. It is 4 by 3. 4 by 3, when you simplify, it would be something like 1.333. Okay, so this is what we have the variance of which problem, students? This is the 31st problem. I hope you have understood this. Is that okay? Right. Then we will then we'll go for the next problem, students. The next problem, I feel I think I can erase this, so it will be easy for us to understand. Okay, um, if we erase this point, these values, and easily I can do it in this same things itself. Okay, so let's do it. I'm going for the next problem, that is the 32nd problem, what it is all about. Let's see. Okay, we'll do it here itself, in this corner itself. We will try to do. What is that we see? We have 32nd problem. Okay, what it is, in a binomial distribution with 5 trials. What is that 5 trials? It's nothing but n is equal to 5. The mean is 3. Mean is 3. Mean is equal to 3. They said find p and standard deviation. We have to find out p, and then we have to find out standard deviation. This is the simple question. They have given n is equal to 5, mean is equal to 3. So what is that? They have asked p. That means n is known to us, p is not known to us. So first thing is we need to find out p. Both the parameters are required for us. So what we'll do, we'll take use of this statement, mean. What is it? Mean is equal to 3. What is the mean of the binomial distribution? Mean of the binomial distribution is np. np is equal to 3. Okay. So what is n? N is 5. 5p is equal to 3, or p is equal to 3 by 5, or we can say 0.6. Fine. P is equal to 3 by 5, or we can also say it as p is equal to 6. This is the answer that we can get it from this. Next is standard deviation. So for standard deviation, we need to know, or we need to find out variance. Variance is n into p into q. What is n? N is 5. P is what? 3 by 5. And when P is 3 by 5, Q will be 2 by 5, students. Is that right? Fine. I showed it right now here. See, 3 times. 1 time you have been successful, 2 times you are failure. Here it is 5 times. In 3 times you are successful, 2 times you will be a failure. So this 5 can cancels. What will happen? 3 into 2 is 6. 6 by 5. So when you see this 6 by 5, so it will be somewhere around 1.2 or so, I think it will be. So this is what is the variance, sorry, standard deviation. This is 1.09. You may get the answer, and this is the value that you get it. Okay. So this is the 32nd problem, students. You can just go back and watch this video once again to know how I have done these problems here. Okay. So next question, we'll go for the next question. Fast I will do, so we can have this video clear to us. Okay, solving all the problems, whatever we have. Okay, fine. Next question, that is the 33rd question. What is the 33rd question? If a binomial distribution has mean 3 and variance 2, find the parameters. If a binomial distribution mean is equal to 3 and variance is equal to 2, find the parameters. Parameters of a binomial distribution is n. We have to find out n, and we also have to find out p. These two values you have to find out. Now let's go with this mean and variance. So what is mean? It is np is equal to 3. Variance means it is npq is equal to 2. Now what we do is, let's substitute the values of np. Np, we know what is np, it is 3. So it is 3q is equal to 2, or in other words, q is equal to 2 by 3. When q is equal to 2 by 3, p is equal to 1 by 3. Students, correct now? Right, p you got one value, then we need to find out n. So we know what is n. We know that according to the question given, np is equal to 3. Now after calculating, you know what is the value of p? The value of p is 1 by 3, that is equal to 3. So if I take this 3 that side, it would be n into 1 is equal to n. N is equal to 3 into 3, it is how much? 9. So n is equal to 9 and p is equal to 1 by 3 is the answer to this question. Okay? Is that clear? Fine. Thank you. So we'll go for the next uh, next question. What is that next question? 34th question. I hope you were following whatever I am explaining to you. Okay, so this is the 34th question. The mean and the standard deviation. Oh, they have given here mean and standard deviation. There they have given mean and variance. So here mean and standard deviation of the binomial distribution are 8 and. Let's take the 34th problem. That is the mean and the standard deviation. The mean, okay, it's given clearly here. The mean and the standard deviation of a binomial distribution are 8 and 2 respectively. Find the parameters. So this is the 34th problem, students. I'm doing it. So what is it? Mean, they said. It's a mean. Okay. Mean is equal to 8. And they have given standard deviation is equal to 2. If in the previous case, in the previous problem here, if you see 33rd problem, you can clearly see here it's almost the same. They also asked here to find the parameters. Here also they asked the same, find the parameters. But the data they have given is quite different from the 34th problem. If a binomial distribution has mean 3 and variance 2, here binomial distribution has mean 8 and standard deviation 2. Okay, so you need to be very careful in understanding this question. So it is mean is NP is equal to 8 and standard deviation of the binomial distribution is root of NPQ is equal to 2. Okay, so let's take this part itself. Now I don't want the root. So when I don't want the root, what I should do is I'll square on both the sides. Square on both the sides. So when I square on both the sides like this, root NPQ, I square it here also and here also I square it. So the square gets cancels with the root here. And what happens here? What remains in the LHS? It is NPQ is equal to 4. Is that okay? I'll write it here. NPQ is equal to 4. That means variance is equal to 4. Now for that we have NP. What is NP? NP is 8. 8Q is equal to 4 or Q is equal to 4 by 8. Or in other words, 4 ones are 4 twos are. That implies very simple, Q is equal to 1 by 2. When Q is 1 by 2, P also will be 1 by 2. Okay. right? You got this one answer, you got it. Then we have NP is equal to 8, that is mean is equal to 8 is what given to us in 34th problem. So n into 1 by 2 is equal to 8. What is this 1 by 2? 1 by 2 is the value p that we got it here. Now I take this to that side, so it would be how much? 2 into 8, it is 16. So n is equal to 16 and p is equal to 1 by 2 is what is the answer to this 34th problem. I hope you have understood all these four, students. Okay, thank you.